You're listening to the Knowledge Archives podcast. Welcome to the Knowledge Archives podcast. We're a group of students on a mission to learn from as many different disciplines of knowledge as possible. I'm your host, Madhav Malhotra, and today I'm lucky to be joined by Dr. Monica Imelko, Professor and Canada Research Chair in Water Science, Technology and Policy at the University of Waterloo in Canada. Her research focuses on drinking water supply and treatment, especially regarding the effects of climate change by wildfires. I'm very excited to learn more about the emerging discoveries in this area today. So thank you for joining me. I really appreciate you taking the time, and I'm very excited to learn more about this emerging discipline that we've been looking into. But first of all, I'd love to just ask you to introduce yourself, how you got started in this area of work.
So my name is Monica Imelko. I'm a professor of civil and environmental engineering at the University of Waterloo. I am also the Canada Research Chair in Water Science, Technology and Policy. I came to Canada from the United States, over 20 years ago now. I've been on faculty as a professor here just about 20 years. And I started off being interested in water as a 13-year-old. Learning about in Girl Scouts, so Girl Guides here in Canada, the importance of water. 1980 was the year of water, and I was 9 years old then. And it just was a recurring theme. I was interested in the environment and in future, in what it would look like. People talked about this concept of climate change. It was a new emerging idea. And it's just something that always stuck with me. I think that for me, one of the most important things about the job I have is, I love science and math. I was always interested in the sciences, but I wanted to do something important for society. And so that's always been with me. So that's how I got to this place.
And thinking about the evolution since, that time when climate change might just be a mystery for you, that might inspire you to now. I know that you're at the forefront of discovering very specific aspects of the impacts of climate change and the problems that emerge that we don't often get to hear about in the public. And when it comes specifically to your research with managing water resources, when we think of water and climate change, we often think of things like droughts or heat waves. But I know that with your recent research, we've started to look more into the effects of wildfires and the effects that it has on our water supply. So how are these two things related? What are some of the impacts that wildfires can have on drinking water supply? And why have we started to become interested in studying this?
Thanks so much for asking the question, because I think sometimes we don't think about where our water comes from. And so if you pause for a minute, you say, where does my drinking water come from? Perhaps if you're in Toronto, you might say, well, Lake Ontario. But where did that water come from? It comes off of the land somewhere. And what a lot of people don't realize is that the land captures water. There's this thing called the water cycle. And in many parts of the world, Canada included, a lot of our water supply, in fact, the majority of our water supply, comes from precipitation. So rain and snow is important in Canada. And it's captured by the landscape. And the majority in Canada is actually captured by trees, by forested landscapes. If you go far back enough, you can even think of some of these larger water supply systems like the Great Lakes ultimately being linked to where their water originates and is on forested landscapes. And so my work has focused very much on not only can I treat water coming out of a pipe to make it safe for consumption, so drinking water treatment, but also can I manage the landscape, protect the landscape actively with action so that that water supply is protected so we don't have so many challenges in treating it. And forests are a major point of origin for our water supplies. And so what's happening with climate change is wildfires are what we often say to as the hardest on water. You can imagine as the landscape changes, it necessarily may have an impact on how that water looks and makes its way downstream to communities. And that's because forests capture or intercept the water. And then as the water makes its way to the ground and into our water supplies, rivers, lakes, it often goes through a natural treatment process. So as it makes its way through the root zone of a forest, there's a natural treatment, a filtration that occurs, a purification, if you will. And there's time associated with that as well. And so we often talk about healthy forests mean healthy water. That doesn't mean you're going to just go and drink a glass of water off the landscape, because there can still be contaminants, especially pathogens, organisms that can make us sick in the water supply. So we still have to treat it. But there are more treatment challenges when we don't have that natural purification. And that is what we're being faced with when we talk about climate change. So my research focus has been for many years now on natural landscape disturbances. And so in the West, that might mean fires. In the East, it might mean hurricanes. When there's blowdown of trees, when that natural purification is less than ideal, that often means an impact on our water supply.
Mm-hmm. And when we connect these essential features, I know in a broad overview, we all know that ecosystems connect together, there are lots of interactions, but when it comes to specifically studying this, I was really astonished by some of your work and the incredible diversity in all of the things I found. Everything from studying the microorganisms in the water to sediments in the water to different statistical methods that we use to run research studies. And regarding that, I was kind of wondering, when it came to your research work and the teams you're working in, what kind of skills are necessary to be able to do this kind of work? Do you rely on a bunch of specialists, a lot of generalists? How does that look like?
I think that's a really interesting question. And again, I think it's quite insightful. So you made the point previously about people think about drought. And what I'm talking about isn't drought. It's about, if you have water, how does its quality change? Because depending on quality, that's going to dictate how much we have to treat it to make it safe for consumption. And you've hit the nail on the head that it's like, well, okay, how do you go about that? You have to think about, where's the water coming from? How can we manage the landscape? If water quality changes, is it physical attributes, chemical attributes, microbiological attributes? And then as we collect those data, how do we quantify them reliably, especially when we're talking about our experimental landscape? When we're talking about a watershed, how many square kilometers is that? Could be 100,000 square kilometers. In the case when we think about the Fort McMurray wildfire and the area that was impacted there, the watershed. So we can be talking about large, diverse masses of land, and then we can get into what's on the surface and what's in the subsurface. So teamwork is critical, because you can't know everything. And over time in your career, do you pick up more and more skills? Absolutely. And so the reality is I think that people can work within their own specialization on certain types of topics, but other topics like water supply and public health protection through the provision of safe drinking water, as impacted by changing climate, and how do we adapt and how do we mitigate, necessarily requires a team approach. And so I think part of it is developing your own skills, and part of it is working with other people with other areas of specialization. And I'm not talking about engineers and chemists working together. Yes, that's part of it, but it's not just the natural sciences and engineering. It is the social sciences. It is the humanities and arts. It's all of us coming together to develop policies, to develop socio-culturally appropriate solutions to these broader challenges. And so the words that I would suggest is, years ago now, people used to talk about interdisciplinary, so between disciplines. And that used to be very, in problem solving, a good route to take, an interdisciplinary route. But an interdisciplinary route is two disciplines working next to each other and occasionally communicating. What we now talk about is transdisciplinary, so actually crossing over into each other's disciplines to start to become a little bit dangerous. Not to become an expert. When you need an expert, you go to an expert, but it's kind of having a group of colleagues that you can draw on and work together over time to actually advance your area of expertise, but also their area of expertise, and perhaps even develop a new area at the interface of those disciplines. So transdisciplinary planarity is really important, and it starts with knowing what your core area of expertise is. And I think this is really important for students in high school. Have a base of knowledge that you really want to be an expert in, but then open your mind to how you can dabble in other disciplines and make an impact by working with other like-minded people to address a particular challenge.
Mm-hmm. I think it's really important to note the general phenomena there, more important than not just this specific research or even research in the natural sciences in general. The idea of working in a transdisciplinary fashion kind of transcends that and can apply to a bunch of different contexts. So that's really amazing advice.
Several of us often say that all the exciting things happen at the interfaces, right? And several of us also are really interested. It's like, well, if I could have done another degree in university, it might have been in this other area. So I often describe myself as somebody with a Discovery Channel level of interest in everything, with a key base of expertise in a specific area.
Yeah. And I think the incredible insight is that that's not just something that is what occurs at an individual level. If we look at the effects that this has had on a industry-wide level or a scientific discipline-wide level, over the past little while, we've started to see a lot of integration of different things, like, say, with the biological work that you do with analyzing microbiology. I'm sure that the technology developed there was a lot of transdisciplinary action on that. And we're starting to see how, from that, exactly as you mentioned, we have these new fields emerging out of it. So, with things like genetic analysis now, it's like become its own subcomponent out of these fields. So, I think it's a really great thing for individuals to further develop themselves, but also to see some of the effects of that and how it's contributing to real research like yours now and enabling a lot of people to act on it.
There are definitely opportunities for cross-application and cross-pollination of ideas. But for all the people who get worried about what about the fundamentals, I think it's also equally important to remember that that fundamental basis of understanding is critical. One of the biggest woes that I often cite is the advent of computing. So bear with me while I explain this, because computers have advanced science tremendously. But with that power comes responsibility. And so one of my biggest complaints, and so you ask, well, you've done this, but then you go into this, how do you quantify uncertainty and get into these aspects of data representation and modeling? Where does that come from? That comes from a fear of doing the wrong thing when it comes to working with numbers. And so let me explain what I mean by that a little bit. What that comes from is the recognition that with computing, we can do so many things, but we can also misuse those computers and that power. And with so much software available and things you can download an app. The challenge is, how do you then use it and apply it? And do you actually know what you're doing? So I think that with all these tools available to us, we're going to really need to think about how to best make sure that we're using them judiciously. Computing, like many things, it's a blessing and a curse, right? And access to computing, but I'm an optimist. And so I think that with the availability of these tools, and artificial intelligence is going to be the next phase, right? How do we use it and make sure that we use it carefully, judiciously, for ultimately the betterment of society?
Yeah. Why don't we get into some of the specifics there? So, with everything that you're doing, one, what are the capabilities that are now possible that wouldn't have been possible a decade ago in terms of studying this topic? But then, two, as you pointed out, and what we don't think as much about, what are the challenges that these technologies have brought?
So, absolutely. The one that comes to mind, or a few that come to mind immediately, are things like spurious correlations. What does that mean? It means that I see a relationship between two parameters, but does it actually make sense? So a simple and obvious example is, and this is one I present in one of my classes, which is stork sightings and live baby births. The more storks we see, the more live baby births we have. And we all know that those two are not correlated. Or to be clear, they are correlated because we can show the data, but it doesn't mean that there's a causal relationship. And all of us can agree that yes, absolutely, that's the case, and this relationship just happens. So that's easy. But when we have all these sophisticated modeling tools available to us, we can actually start to believe that because we see a relationship, that it actually describes a phenomena or it is causal. That's simply not the case. And if we take that and extend that a bit further now to artificial intelligence and machine learning, it gets into a really interesting space, because all of a sudden you're saying, well, I see these trends, but what do they mean? And so one of the big concerns with scientists is that we're going to be, or some scientists, is we're going to be so much in that space of trying to interpret these trends that we may be missing other factors that we didn't consider in establishing those relationships. So our understanding of scientific phenomena and processes might become weaker. And so this starts to really get into a place of, do you want to make decisions based on correlations where a computer can look at so many possible scenarios so much more quickly than a human brain could ever do? And on average see trends, and then do we want to interpret meaning into them? And so you hear about scenarios where you've seen some of these really simple AI experiments where we have robots in airports, and how humans have started to interact with them and actually modify the results based on how they interact with them. And so there are examples of these little robots learning a whole language that they weren't initially expected to learn, because humans are interacting with them and trying to see if they can poke at them a bit and push them in a direction where all of a sudden they're going to start using an appropriate language. And so they've had to be removed. But it underscores challenges in the relationship. And so do I think that there's room for artificial intelligence to do amazing things? Absolutely. But what it also brings up is an area that most people interested in natural sciences and engineering don't think about, which is ethics. Ethics and utilization of technology. So that's going to be explosive in the future, and it's necessarily going to be about what we value. It's going to be a debate. So ethics and technology is what you are going to be facing in the future, because it's going to become so predominant everywhere. What can Alexa do in your household, or what should Alexa not be allowed to do? How much can information flow, and personal information? There's been a huge shift in society with respect to the availability of personal information. And so now if I want to bring that back down to the community level and to what I'm doing, what does it come down to? What kinds of data are available? Are the sensors that I need to generate those data available? Are the people who are building the models using the right data? And I don't mean in terms of the flavors or the actual metrics. I mean in terms of the temporal scale. So let me give you an example. You brought up hydrologists. And I've had, over the course of my career, a really interesting experience about learning to speak the same language. So we're all water scientists, hydrologists, chemists. I'm an environmental engineer. And we're talking about forests and fire. And I'm talking about the impacts to the provision of safe drinking water. And the hydrologists are saying, well, wow, we had this fire. And in terms of water chemistry measured as nitrogen, for example, fire recovered pretty quickly. And on the scale of forest recovery, it recovered pretty quickly. And so somebody might walk away and say, okay, no problems for drinking water, except that recovery to a hydrologist means 3 to 4 years. So in 3 to 4 years, things return back to some baseline. And a drinking water treatment engineer like me says, what, are you crazy? Rapid recovery is 3 to 4 hours, not 3 to 4 years. Are you going to go without safe drinking water potentially because your water treatment plant is challenged for 3 to 4 years? I don't think so. And so what that underscores is that we use words and we communicate with one another, but how we interpret them, and therefore how we model them, because models are representations of reality, or the main points of reality that we care about. Boy, oh boy, we better understand each other. And so that means we need to understand literally what the words mean that we're saying. We need to be able to communicate well, because without that, you can't build your AI model. And without an understanding of the components that need to go into it, and do the sensors exist so that we can actually even start to apply a machine learning based approach to solving certain problems. At this point in time, some of those data just aren't available. And a machine learning approach is only as good as its inputs. And then the example I gave you from the robots in the airport is, what if somebody can modify those inputs and start to make something else significant, even though really it has nothing to do with the problem you're trying to solve, right? All of a sudden you start to think about how some more devious things can be done with models. And so how much really should we rely on them? And do we really need to be comfortable in understanding what they're doing? So there are a lot of ethical, philosophical questions that are evolving in the application of science and technology that really did not exist at the same scale as before. And so we have to start making sure, it all starts with making sure that we're not afraid of asking questions and that we're speaking the same language, and truly understand each other, even when we use words that we all think are a normal part of our everyday lexicon, like the example I gave you with recovery. So it's going to be a different playing field in the future, and it's exciting and it's fun, but you have to be comfortable with asking a lot of questions and making sure that you understand your colleagues that you're speaking with. And usually that's not an introductory point to discussion when you're talking about either engineering or science.
Yeah, I think that ties back to the interdisciplinary point that you were making. And it makes me think about my personal experience in high school. Some of the most useful classes I've had, even though I want to go into STEM, have been English or epistemology. The reason being that although it is important to build foundations where you learn mathematics, where you learn sciences and theories, it's a lot more important to think about the questions that you have to ask yourself. And I think that in the future, you are right that a lot of us are going to have to rethink what it means to be, say, a climate scientist or an environmental engineer and the issues we're going to be thinking about.
Yes, for sure. And the tools you have available to you, and to not run away with them just because you can, just because you have a program or is downloadable freeware, right? And it's statistical analysis. You have to understand what R is doing, and you have to know if you're relying on a specific piece of code, if it's actually good. So those foundations are critical, and you need to know, I always talk about stay in your lane, especially as you get older and more experienced. It's important to know what you really know well, and it's important to know what you can dabble in but you don't really know so well. And it's important to be comfortable with the fact that you can't know everything. In this day and age, I can Google anything and find some really good information. In fact, the word Google has become a verb now, and everybody knows what I mean when I say it. I can search anything online and I can get some information. And so developing those analytical skills and questioning if what I'm reading is accurate and if it's supported with good science. There's so much junk science out there now because anybody can publish anything. We don't know if it's any good, right? There's a lot of junk science out there. And I think that that's a contributing factor to why people are losing faith in science. And so it's important to develop those discriminatory skill sets to make sure that you can really come to a point of what you believe is good science. And it's important to have a high bar for science. So these are skills that a lot of us 20, 30 years ago, 40 years ago, these skills were always important, but never as important as they are today because technology is advancing so rapidly. But it's also exciting because even if we can, I was talking about correlations before in a bad way, but you know what? For exploration, why are these things correlated? I never would have thought of this. Maybe this is something I should explore some more. Maybe I can explain it. So you can just as much as you can cast some of these tools in a concerning light, you can also cast them in a very exciting, positive light. And so it comes down to making sure that we're very careful and thoughtful about how we use them. But more tools is always a good thing, right?
I think that it's kind of like a Pandora's box. The more we open things, the more we have to worry about. But I think it's a great note to kind of bring this conversation to a close, thinking about what the future of not just this field, but in general, scientific disciplines and even beyond that, just the process of gathering knowledge will look like. And so finally, I wanted to ask you to further this kind of research in your specific field, in the research on climate change in general. We talked about some of the things that are important for individuals to take part in, to educate themselves on how to delve into this kind of information. Are there any other barriers that need to be addressed by governments, by scientists, by even companies to make sure that we're not just doing research on climate change and especially on these new effects that we're discovering, but applying it in a critical manner?
I think that first and foremost, I hate that I have to say this, is let's recognize that climate change is real and it's here. That is the starting point. And by saying that, what that means is it affects everybody. There is no group, industry, technology that is immune from it. Let me give you a for example. If we think about landscapes, mining, looking after the earth overall, cell phones and technologies, our devices, are they affected by climate change? our access to the rare earth metals that makes the chips in these technologies, and what that does to the environment and what the feedbacks are in their production. That's one simplistic example, but the point is climate change is real and it's marching along, and we are at a point now where we need to adapt and mitigate. It is not prevent, it is not go back. And I think that the question really is to be complete in our thinking with respect to, in what all ways, in what I'm doing, does this have an impact? And then what can we do individually, at the community scale, at the government scale, to address these challenges? And so governments have to be transparent and as complete and possible as they're thinking, in their thinking. And necessarily, I believe what that means is facilitating connections between disciplines. Yes, you have to have expertise within one discipline, but what we do in one discipline may have actually a negative impact or a co-benefit on another discipline. So it's about really linking those benefits together and enabling us to have the discussion. And that's hard, it's expensive, it requires this collective, connected thinking. And that doesn't happen overnight. So it needs to be an ongoing discussion and an ongoing attempt to connect people. And that becomes really challenging because it's expensive. But it can't be a part-time commitment. You either do it or you don't. And I think that's our challenge. I think we're really lucky to live in Canada because thus far it seems that there is a recognition and a commitment to this discussion. And what we need most of all are educated young voices and emerging scientists of all kinds to come and speak to this discussion and to come with an open mind to advance these issues, to ultimately have science-driven policy. It's bringing people together for a common cause and taking off, climate change in and of itself is such a big problem. So what can we do in bite-sized pieces, right? What can we manageably address and advance, recognizing that there needs to be a concerted approach across various issues of challenge. It's a systems approach to thinking. And the system is, of course, our Earth.
Yeah. I think that's an incredible thought to wrap up on. And it's just astonishing to me to notice with the system that you're thinking about everything from your impact in it, how you can be the best scientist contributing to this, how your team can resolve some of the issues, to how individuals can step up and be part of this, all the way to what government stakeholders or public opinion has involved in this. So I think it's incredible to note all of these complicated ideas, and it's been amazing to hear about all of the things you're thinking about, all of these nuanced details that we're going to have to be thinking about in this discussion next. So I really appreciate you taking the time to provide all of these thoughts today.
Thank you so much for your interest in this topic. It is indeed a discussion we should all be having, and it's a team effort. And so more heads are always better than one. This is a great area to be in because you can wake up in the morning and know you're doing something good for society. You can actually change the world. So thank you so much for having me. And I will be excited to hear about what you do in your future as well.